Hello everyone, today we'll discuss about question 9. So now let us first read through the question. It asks us to sketch the curve, and here's the equation given. And also for two cases. The first case, a and b both bigger than 0. The second case, a smaller than 0, b bigger than 0. And also we need to prove that this equation, if it satisfies this inequality, it will have three distinct real roots, and if it satisfies this inequality, fewer than three distinct real roots. So now let's get started. First, we may think we need to sketch the curve. So in order to sketch the curve, we need to find out the stationary point, and it leads us to think about we need to first calculate the f, like the first derivative of x, which is equals to 3x squared plus 2ax. And also, if we want to find out the stationary point, the first derivative of x is equal to 0. So 3x squared plus 2ax equals to 0. We got x equals to 0, or x equals to negative 2 over 3a. So after we get these roots, we need also to determine whether they are the relative maximum value or the relative minimum value. So we need to get f second derivative of x, which is 6x plus 2a. We first substitute x equals to 0. It will give us the value of 2a. We next substitute x equals to negative 2 over 3a. Negative. We got the value of negative 2a. So for the first case, when a is bigger than 0, b is bigger than 0. When x equals to 0, the value 2a is bigger than 0. X equals to negative 2 over 3a, the value negative 2a is smaller than 0. So if the value is bigger than 0, it will be the relative minimum point. And if the value is smaller than 0, it will be the relative maximum point. So we may draw something probably not that serious. First, we need to, it of course starts from the negative infinite and then increase to the when x equals to negative 2 over 3a, and then decrease because it is the maximum point, and decrease till x equals to 0, which is the minimum point, and then start increase again to positive infinite. Okay, so after we get the idea, we can sketch our graph. Here's the x-axis. Here's the y-axis. So, first, it starts from negative infinite. But we knew one thing is that because b is bigger than 0. So, if x equals to 0 in this equation, we will know that y equals to b. So, when x equals to 0, it must lay on the positive half of the y-axis. So, started from the negative infinite to here, where x equals to negative 2 over 3a, and then it will decrease till here. It needs to be a curve. Decrease to here when x equals to 0. This is b. Okay, so now it will again increase to positive infinite. And this is how we sketch the first graph. And for the second graph, when a is smaller than 0, b is bigger than 0, we will have when x equals to 0, the second derivative of x equals to 2a, x equals to negative 2 over 3a, the second derivative of x equals to negative 2a, but here 2a is smaller than 0, negative 2a is bigger than 0, so this is the relative, of course, maximum point, and if bigger than 0, it is relative minimum point. So it also starts from negative infinite, and then increase to x equals to 0, and decrease to x equals to 2 over 3, negative 2 over 3a, and increase to positive infinite. And here, again, when x equals to 0, we also have y equals to b, which is also in the positive half of the y-axis. Okay, so now we get those two graphs. Okay, so from negative, we first reach the positive one. Here, when x equals to 0, it is b. b is positive, so we first reach here. And then we will decrease to y when x equals to negative, let's say here, negative 2 over 3a. And then, because negative 2 over 3a, and then we will increase again to positive infinite. And this is how I would say the graph look like, because yes, we will find those two stationary point, and this one is the minimum point, and then it increase the trend is correct. And again, we need to to prove the equation x cubed plus ax squared plus b equals to 0. Like it's satisfied with those two equations. So first we need to acknowledge something, that is, in order to find the delta in the cubic function, it is if the normal function of cubic function is of course x cubed plus px squared plus qx plus r. So that is equal to 0. So the delta would be 18pqr minus 4p cubed r plus p squared q squared minus 4q cubed minus 27r squared. So in this equation, wait a moment, we need to know that if delta is bigger than 0, three distinct roots. Delta is equal to 0, it's one distinct root with other two roots probably not in the real value range, and also when delta is smaller than 0, like there is to be like the repeated root. So we just simply substitute a equals to here p equals to a, q equals to 0, and r equals to b. We'll get the function's own delta, which is negative 4a cubed b minus 27b squared. So we can spot some similarity of these two inequality and this one. So after we factorize it, it will look like this. Delta equals to negative b 4a cubed plus 27b. So again, if 27b squared plus 4a cube b is smaller than 0, which is if plus equals to 0, and then it means when delta is bigger than 0, because this one is smaller than 0, so negative a positive sign in the bracket would be a smaller than 0 sign will be bigger than 0. So if it satisfies inequality 1, it will be delta bigger than 0, which equals to 3 distinct roots. And if delta equals to negative 4a cubed b plus 27b squared, if this is bigger than 0, delta smaller than 0, which is only one distinct smaller than 3. Which proved the two inequalities. Okay, so now this is the end of the analysis of question 9. Thank you.